here's our video on arithmetic sequences. So what is a sequence? A sequence is a pattern. It's a arrangement, a pattern arranged in some order. You know, for example, if we saw 1, 2, 3, 4, right, dot, 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 you can assume, you can make a logical guess based on the pattern you see that the next number is 5. So here's an example. Let's say you're riding in an Uber cab down Columbus Avenue in Manhattan, and you notice that the streets you pass are going down in number. So if you're in Manhattan, if the numbers are going down, you must be going south, right? So here's Columbus Avenue. Let's say you're going down here. Here's the Museum of Natural History on the west side of Manhattan. So it's kind of blurry here, but we have 72nd Street here, and this is 71st, and that's 70th. So that's 69th, 68th, 67th Street. So we can make an educated guess as we're seeing a pattern that this must be 66th Street, and that must be 65th, right? So that is our educated guess. We're seeing a pattern. And we see a pattern and we make a guess like that. We're saying that our conjecture, and we'll talk about this term again, conjecture, is our answer. So our conclusion, our conjecture, is based on inductive reasoning. So we got to remember this term here, inductive reasoning. And you'll learn a lot more about inductive reasoning in geometry. So again, with inductive reasoning, you're making conclusions or conjectures based on patterns and observations. Okay. So let's look at this pattern here. We have 12, 15, 18, 21. So maybe we can see what the pattern is. What is the rule that can help us find the next number? Well, if we look at this, we can see that there's a difference between each number of 3. So we're making a conjecture that the next number should be 24. And the next number after that should be 27, and so on. Our conjecture is that's the next number. So again, our conclusion or our answer is called a conjecture. So far you should know what inductive reasoning is and conjecture. Let's go back to this sequence we had here, this number pattern. And each number is a term. So that's a term, that's the first term. Second term, the third term, the fourth term. And we already remember the fifth term, we said it was 24. And the sixth term, we said is 27. So this is how we would write the terms in math. This capital, this lowercase, that is, lowercase a, and this subscript. This is a subscript, not a superscript. A superscript is like an exponent, but this is a subscript, and all it says is that's the first term. And we said the first term was 12, and the second term we said is 15. So what does that mean? Well, that means that's the third term, which we said was 18. That's the fourth term, which we said was 21. So what would this be? What would that be, and what would the answer be? That's the seventh term. What do you think the seventh term is? Okay, 30. Good. Okay. So here's our terms. First term, second term, third term, and so forth. And we said that the next term is 24, so 24 is the fifth term, and that's again how we write it. So what if we wanted to know the 30th term, or any other term? So any other term is the nth term. So in our pattern here, we started with 12, and we had 15, we had 18, 21, 24, and so on. And the nth term is some number down the road. That's what the nth term is. Until we define it, we don't know what it is, but we know that that pattern will keep going to the nth term. Of course, it's infinite, right? So the first thing you want to do if you want to find the 30th term is you want to find the difference in the pattern. So the difference in the pattern we can see is 3. Between each number is 3. And we talked about that before. So D for difference is 3. That's the first thing you want to do. And then we're going to use a formula that may, and I circled may because we're not sure, that may have been invented by a guy named Carl Gauss, who lived around the 1700s. He was a child prodigy in math. And there's a funny story. And in the story, when he was in elementary school, or primary school as they called it in Germany, the teacher wanted the kids to, he put a sequence of numbers, 1 plus 2 plus 3 plus 4, and he wanted them to add all these numbers all the way to 100. And he thought that would take the kids a long time, so the teacher could then sit on his desk and fall asleep if he wanted to. So Carl Gauss, using observations and patterns, he came up with the answer right away. Some say it took him 30 seconds. Do you think you know the answer to that? Well, it may take you a while, or maybe you're a genius like Carl Gauss, but the answer is 50-50. Well, let's talk about the story. What Gauss did, again, he took a sequence of numbers. That's what the teacher wanted him to do, and to add it. What Gauss did is he looked at a pattern. He said, well, 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. So as the numbers go up on the left, the numbers go down on the right, and then he came to 50 plus 51, and that came out to be 101. So what he did is he's saying, well, I have 101 50 times, and he came up with 50-50. Okay, now when you're trying to find the sum of a sequence, like Gauss did, that's called a series. And we'll talk about a series in the next video. But now we're just talking about a sequence. So this is a sequence of numbers. And if we wanted to know what the sum of this sequence would be, that's called a series, which again we'll talk about in the next video. So let's go back to our sequence here. 12, 15, 18, 21. We know the difference is 3. And let's say we want to find the 30th term. So this is the formula we're going to use. A to the nth, remember the nth term, is the term we're trying to find. So in this case, we're trying to find the 30th term. So we can write it like this. We're trying to find the 30th term. With the formula, we're going to use the first term plus 30, because 30 is the term we're looking for, minus 1 times the difference. Remember, you should know GEMDIS or PEMDIS, as it used to be called. So again, the difference is 3. We're saying that we're trying to find the 30th term. The first term is 12. Right here, it's the first term. We're trying to find the 30th term, so we'll plug in 30 for n. 30 minus 1 times the difference of 3. Okay, and this is what we'll get here. So we'll get 30 minus 1 is 29. We have to do parentheses first. 29 times 3 is 87. And 87 plus 12 gives us 99. That's the 30th term. So again, this is the formula. And as we do this, and as you do this over and over again, you'll memorize the formula pretty easily. Okay, so let's see what you can do. Here's our pattern. Try to find the 203rd term. Now again, you can do this without the formula. You can just do this until you get to the 203rd term. That may take you a while. But algebra makes things a little easier. So see what you can do with that. You should pause the tape. Alright. So we can see that the difference between 7, 11, 15, and 19 is 4. So that's the difference. And we're trying to find the 203rd term. The first term is 7. The nth term we're trying to find is 203. So 203 minus 1 times 4. So you should have got to this point at least. Rewind the tape if you didn't get there. Okay. So 203 minus 1 is 202. So we want to do 202 times 4. Remember, GEMDIS first. 202 times 4 is 108. And 108 plus 7 is 115. That's the 203rd term. Okay, so you should rewind the tape if you didn't understand that. And we have other sequences we can talk about later. This was the arithmetic sequence, but there's also a geometric sequence, and there's exponential sequences we'll talk about.